This is another video regarding periodic trends of the periodic table in this series. Okay, this periodic trend that we're going to look at is called electron affinity. Now, affinity, think of if you have an affinity for something, you are attracted or I don't know, added to. But for me, affinity references the word attraction or alike. Okay, so electron affinity is defined as the energy released when the following reaction occurs. Let's look at this reaction. We have an element, and what are we doing to it? We are adding an electron. Okay, we are adding an electron to this atom to create an ion. Okay, so electron affinity, an affection, an attraction, an addition of an electron. Okay, so electron affinity is defined as the energy that's released when an atom has the addition, the addition of an electron to it. Okay? Now, when you add an electron to an atom, it does cause a release of energy. So these are defined as exothermic reactions, an exothermic process, because energy is given off. Okay. Now, the trend that we see, is as you move across a period. Okay, remember, a period is a row on the periodic table. As you move across the periodic table, you're moving from metals to nonmetals. As you move across, see sodium and magnesium metal over to aluminum, then you're moving into silicon and metalloid, phosphorus, sulfur, chlorine, all nonmetals, argon. We're moving over from metals to nonmetals. Okay, if we think about that, and what type of ions that elements form, metals, your metals here like sodium, magnesium, aluminum, those form positive ions we called cations, and the nonmetals like chlorine and sulfur and oxygen and fluorine and that form negative ions called anions. So who has a greater affection, a greater attraction for electrons? It would be the elements, the non-metal elements, because they tend to form negative ions when they react. So looks like the addition of electrons would favor non-metal elements. So what does that help us see? That helps us see that as we move across a period, across a row, we're moving from metals to the non-metal elements, that we would see an increase, a steady increase in the amount of energy that is released. Because the non-metal atoms, those tend to gain, to attract electrons when they react. So the addition of an electron would be welcomed by them, whereas metals, what do we see metals do? When they react, they tend to lose electrons and form those positive ions called cations. So they're not in the business of adding electrons, they're in the business of losing electrons. So they would have what we consider a low affinity, a low attraction for electrons. So they would be lower. So as we move across a period, we see a steady increase in the affinity, in that attraction for an electron. So we're going to see a greater energy release because there's a greater desire for it. And the trend that we see when we move down the table, as we move down the table, we would go from like carbon, a nonmetal, to silicon, a metalloid, to germanium and tin and lead, to metals. So again, let's look at this. Non-metals, metalloid, metals, non-metals, non-metals, metals down here. See bismuth. So we would see a great affinity up here, a great attraction for electrons for the addition of them. And down here we would see a lower, because we see our metals down here. We see our non-metals up here. Okay, over on the left side, as we move down the groups, we see that steady decrease in the affinity. Okay, so our greatest affinities, okay, our greatest attraction for electrons. So the greatest energy released when we add an electron would be right up here with your fluorines and chlorines in this area, okay, in these nonmetal areas. Okay, so electron affinity, it's a measurement of the energy released when you add an electron to the atom.